Hello, let's continue our Sudoku adventure with Let It Snow by GDC. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have snowflakes and clouds in the grid. So there's going to be a 2-digit number in the clouds, and digits on one or more of the snowflakes on the left side of the grid sum to whatever's in the cloud. So let's say this was 1, 2. That would be 12. And that would mean that these one or more of these digits sum to 12. Over here, if this was 12, that would be one or more of these digits sum to 12. So maybe this could be 6, 1, 2, 3. It doesn't matter what these are. Just some of the snowflakes sum to the 2-digit number. All right. And those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I unintentionally kind of gave this away because there really is only one way to do it. The minimum 2-digit number we can put here is 12. And the maximum that any of these snowflakes can add to is 6 plus 6, which is 12. So these are gimmies. This is 1, 2, this is 6, 6. Now, this is minimum 3, 4. Should we think about the maximum these add to? That's probably helpful. So the maximum this could be, because of the, actually, let's do the boxes. So it's 4 cells in the box. 3, 4, 5, 6 would be the maximum. You could add that, not too hard, but one way we could do this is we know that 1 through 6 is 21. If you have that memorized, then we just have to subtract 3 from that because we're just missing the 1 and 2, which go here in that case. And so that would sum to, 21 minus 3 sums to 18. So this would be 18. This would be 18. 18 plus 18 is 20 plus 16, 36. So this has to be a 3. We cannot exceed 30 something. This is 4, 5, or 6. We don't know what it adds to yet. But I think we're going to have to use most, if not all, of these snowflakes. We know there's a 4 up here. We know there's a 5 and a 6 up here. Is there any way we can see? 36 is our max, and 34 is our minimum. We can only be missing 2. So we could do 3, 4, 5, 6, or we could do as low as 2 less than that. So how would we subtract 2? We can't subtract 2 from the 5, and we can't subtract 2 from the 6, so that would repeat the 3 or 4. So we're going to have a 5 and a 6 in both of these snowflakes. So this has to be a 6. Let me go over that really carefully, because I think I didn't explain that very well. 3, 4, 5, 6 is the maximum. If both of these were 3, 4, 5, 6, I'd add to 36. The minimum is 34. So how would I subtract 2 from this total? See, I haven't proven that we're using all of them, though. I don't think that matters. Even if we used all of them, I would still need the 5 and the 6 to be present in both. Because if I didn't, then I'd be subtracting at least 3, because I'd be replacing it with a 1 or a 2. I hope that makes sense. If I remove, say, the 6 from here, let's say this wasn't 6, so I didn't have 6 at all in here. What's the digit I could add to here? Well, I'd be adding a 2 to here at maximum. And now that subtracts 4 from the sum, because I subtracted 6 and added 2. So I definitely have to have a 6. If I subtracted the 5 from here, if I didn't have a 5 in any of these, I'd still be adding a 1 or a 2 maximum. That still subtracts 3. I'm not allowed to subtract 3. I can only subtract up to 2. So that means that we definitely have the 6 here. And that means that this is a 5, 6 pair, because we can't omit the 5 and 6. So that's our 5, that's our 6. Is there more I can do here? We know there's a 1 in one of these 2 cells. Can this be a 1? Yeah, if I removed the 3, I could replace it with a 1. So this would be a 3, this would be a 1. That's the only way. If this was a 1, this would have to be 3. Seems to be okay. 1 and 2 are up here. So how do I continue this? Does it have to do with where this digit goes in one of these boxes? Maybe not. It's one of these 2. These 2 6s look up. Placing this 6. Okay, so now we know the sum is 36. If the sum is 36, then this has to be 3, 4. That's our 4, that's our 3. And then this has to be 3, 4, 5. Oops, 3, 4, 5. So that's our 5, that's our 4, that's our 3. Okay. Easy enough. Okay. These ones pointing over tell us that's 1, that's 2. That places the 2 there. This is 1, 3, 4. It's not a 1, that's not a 4. Should be Sudoku from here. This is 2. Yeah, the 2 goes here. This is a 4 now. This is 1 and 5. The 5 tells us that's 1, 5. Over here, we need 3 and 4. That does make a 3, 4 pair. So we're missing the 5 that goes there. This is 1, 3, but the 3 tells us that's 1, 3, 4, and 1. That's 3 and 4. This is our 5. Down here, we need a 2 and a 3. So that's 2 and 3. Then down here, we get a 3 in the corner. So it's snowflakey. I need a 1 and I need a 2, and we're done. Alrighty, cool. It was neat. I mean, he could have said use all the snowflakes, but it actually worked out to say that you have to use all of them, even if you could have omitted some. So that was neat. Just had to do a little bit of Sudoku to prove this was 3, 6, because ambiguous says 4, 5, 6. It was a little harder to think about. So if I'd seen that earlier, I didn't have to think as much. But yeah, I had fun. Let me know how you did. If you enjoyed it, why don't leave a like, subscribe, and a kind comment below.